Hey there, Trig rock stars. This is Dr. Platko. Welcome to Flip This Classroom. Good evening, good afternoon. I hope you're doing well. We're on 5.4a, and I need you to head to the identity outline part 2. We need to fill in some new identities. These identities actually do not need to be memorized. You just need to know how to work with them. So let's go ahead and start writing some of them down. The first set is called sum and difference identities, and we will use these for 5.4a and b. Sum and difference identities. Let's say you're walking around at, I don't know, at the park or headed into a store and you are so frustrated because all this time we've been finding what's the sign of 30 degrees and the sign of 60 degrees, and we can find the sign of 90 degrees, but have you ever wondered how to exactly find the sign of 75 degrees? I know it's crossed your mind. So what we need to think about is how we make this a sum, meaning we know the sign of 30 degrees. That's something we're privy to. And we also know the sign of 45 degrees. And so maybe if we can figure out an identity, we could figure out a way to make this work. So for your questions regarding all of these identities that we've ever done, the sign of u plus v, meaning we're going to add two angles together to make 75, is sine of u cosine of v plus cosine of u times the sine of v. Careful with your u's and your v's, they get kind of confusing. We might need to use a difference sometime, sine of u minus v. It's very similar. Sine of u cosine of v. Keep the same sign, minus cosine of u sine of v. When you're learning new math concepts, you really need to look for patterns. This takes the sine and the cosine, the product of them, and the sine and the cosine product, and they just switch the angles, u and v and u and v. Here it was a sine of u, here it's cosine of u. Okay, we also have identities for cosine of u plus v. This one has a little pattern. It goes cosine, cosine, sine, sine. Cosine of u, cosine of v. There's a sign change here. Minus sine of u, sine of v. Cosine of u minus v, I hope you could guess what it would be. Again, it's cosine, cosine, sine, sine. Cosine u, cosine v, a sign change, meaning if you saw a negative sign over here or subtraction, this is addition. Plus sine of u, sine of v. Last but not least, there's tangent. I think I'm going to write tangent over here. Tangent of u plus v equals tangent of u plus tangent of v divided by 1 minus tangent u, tangent v. And tangent of u minus v equals tangent of u minus tangent of v divided by 1 minus, no, 1 plus tangent of u, tangent of v. So those are the ways that we can figure out how to deal with awesome angles like 75 or 105 or things that we haven't dealt with before. So again, these don't have to be memorized, but I need you to be able to handle them. And I also want you to think about how we'd prove this. How would we prove that this is equivalent to this? Okay, so let's move on to our notes. 5.4a, sum and difference identities. The main idea here is that you can't distribute a function. So some people will think that the sine of 30 degrees plus the sine of 60 degrees might be possible that we could say, oh, that's the sine of 30 plus the sine of 60. Well, unfortunately, it doesn't work this way. This is not allowed. Meaning you can't distribute a function. You can distribute values, but not functions. So you guys know that the sine of 30 plus the sine of 60 is really the sine of 90 degrees. And you guys know what that is. That's 1. Well, is that equal to the sine of 30, which is 1/2, plus the sine of 60, which is root 3 over 2? We're not going to get 2 over 2 there. So that is what we're saying. The main idea is that you cannot distribute a function. Okay? So find the exact value using sum or difference identities. Exact value means that we are using no decimals. There is no reason to get these problems incorrect because you can check on your calculator. However, you have to make sure that you are showing your work very carefully and very neatly. There's a lot of fractions, a lot of simplifying. If you can't read it, you're going to get lost. So this is a cosine problem, and I see a 75 there, and this requires some creativity. Since I just talked about 75, it's a little bit easier, but you need to basically use your values on the angle values on the unit circle to make a 75. And you could use sum or difference. For this example, I'm going to use a sum. So it's 30 degrees plus 45 degrees because 75 is equivalent to 30 plus 45. So I have done the correct procedure here. This is a sum of cosines. So we are applying this formula. Cosine is cosine, cosine, sine, sine. Cosine of u, cosine of v, sign change. If it's plus here, it's minus here. Sine of u, sine of v. And in our situation, u is 30 and v is 45. So this will be the cosine of 30 cosine of times the cosine of 45 minus the sine of 30 times the sine of 45. Luckily, you've memorized these. The cosine of 30, the x value of 30, root 3 divided by 2. The cosine at 45, positive root 2 divided by 2. Subtraction sign. Sine of 30 is 1/2, and the sine of 45 is root 2 divided by 2. Order of operations. We need to multiply before we subtract. So root 3 times root 2, you are allowed to multiply radicals. It's root 6 over 4. Multiply the denominators and the numerators. Minus 1 times root 2, which is root 2 over 4. Since we have a common denominator, we can make these two terms into 1. So our denominator is over 4. However, root 6 minus root 2 cannot be simplified. So you just leave it. Root 6 minus root 2 over 4. Now, on your calculator, you can check, as long as you understand order of operations. So if you type in square root of 6, you have to close those parentheses, minus the square root of 2. You need to do all of that operation before dividing by 4. So you could have either put it in parentheses and typed in one whole problem, is approximately 0.2588. So what we want to check is if the cosine of 75 is really approximately 0.2588. I bet you need to check your mode. We've been in radians for a while. So type in cosine of 75 degrees. Hit enter. You have done the problem correctly. Good for you. Happiness. Let's move on. Tangent of 195, I'd like you to use differences just for the practice. So how can we get 195 using a difference? So obviously we need to be thinking about somewhere in 200 because we have to be bigger than 195. So tangent of, let's see, a 225 minus 30. You're following your tangent, a difference of tangents, so u minus v. And the formula for that is tangent of u minus tangent of v divided by 1 plus tangent u tangent v. Now this gets really exciting because tangents are all fractions. So we really need to write neatly here. So we are doing tangent of u is the tangent of 220. I need to double check my formula and make sure that's right. It is. Tangent of 225 minus the tangent of 30, all divided by 1 plus the tangent of 225 nope, times the tangent of 30. If you want to go off to the side and think about what these values are, you can. Tangent of 225 is down here. So that would be a negative negative. So I know that tangent's positive right there. It's a positive 1. So 1 minus, now I need the tangent of 30 degrees. Well, 30 is right here. The y value is 1/2. The x value is root 3 over 2. And we have had a lot of experience with that. That would be root 3 over 3 after we rationalized. So 1 minus root 3 divided by 3, all divided by 1 plus, there's tangent of 225 again, it's positive 1, and then times the tangent of 30 this time, so that would be root 3 divided by 3. I hope you are ready to work with some fractions. Complex fractions means we need a common denominator on the top. So this is really 1 divided by 1. So I'm going to multiply it by 3 and 3 so that this is common. So I have 3 minus the square root of 3, all divided by the same denominator, 3. Bigger bar.
Miss Lamori, please call the office. Kristen Lamori, call the office.
The denominator on this fraction is 3, so I need to get a 3 on this fraction. So 3 plus the square root of 3 is my numerator down here, all divided by the same number, 3. This is looking good so far. So dividing by fractions is easy as pie. You know the rest. I instantly see that these 3's go away. You guys might not be there in your math career. So I'm going to take this fraction and multiply by the reciprocal of this one. 3's cancel, and that's the only thing, because the only thing that this could simplify with is another 3 minus the square root of 3. So I hope that you have quite a bit of space on your paper here. We have 3 minus root 3 over 3 plus root 3. And the only way to simplify this is to rationalize it and get rid of the radical in the denominator. The way that you achieve that, and you need to know this, is to multiply by the conjugate of the denominator. So conjugate means that you take this plus sign and change it to a minus. So we're going to multiply this by 3 minus root 3. And we have to do that on the top because we have to make this expression, its value has to be 1. So I'm going to put a little note here, conjugate of the denominator. That's how we achieve this simplification process. Oh, look at all this fun we get to have. We need to multiply two binomials. So first, 3 times 3 is 9. Outside is negative 3 root 3. Inside, negative 3 root 3. And last is a negative times a negative is a positive. Root 3 times root 3 is root 9, so that will be 3. Your denominator, 3 times 3 is 9. Outside is negative 3 root 3. Inside is positive 3 root 3. We did that on purpose. A positive times a negative is a negative, and root 3 times root 3 is 3. Remember, you do not want to cross off these 9's. You have to simplify the numerator and the denominator before you start simplifying. So we have 9. Lose 3 root 3 and another 3 root 3. You've lost 6 root 3. I apologize. Let's change that 9 to a 12. Because 9 plus 3 is 12. All divided by 9 minus 3, which is 6. And then these have taken off. Now, the only way that you can simplify, since we're dividing by 6, is if both of these terms are divisible by 6. So if I divide everything by 6, I get 1 down here, I get 2 here, and I get a 1 here. So your final answer should be 2 minus the square root of 3. Happiness. You did a great job. You can always double check on your calculator, and I suggest that you do that. Luckily, we get to do this in radians as well. So here we are with sine of pi over 12. And this is where some students get a little bit more flustered because of the fractions. So I'm just telling you right now that you just need to be willing to try, and maybe you won't do it right the first time or the second time or the third time, but you need to make sure that you set up this problem correctly. I want to give you some guidance, and I want to make sure that we use differences when we do this problem, okay? Especially because we're getting 1/12. That's the coefficient up here, 1 pi over 12. You know, there's very few, it would be difficult to add up to get positive 1/12. Unless, no, I'm not going to say that. Okay, so the goal is to get 1/12 or pi over 12 using things that we know. Well, I know that fourths and thirds come to my mind because we have been experiencing things like pi over 4, pi over 3, pi over 2, pi over 6. So you can make pi over 12 however you want to. I like the 4s and 3s because I know that if I get a common denominator, it'll be 3/4, 3/12, and 4/12. So I know that 4 pi over 12 minus 3 pi over 12, sorry about that, ah, 4 pi over 12 minus 3 pi over 12 would equal 1 pi over 12. Well, we don't usually work in 12s, we have before, but 4 over 12 reduces to pi over 3, and 3 over 12 reduces to pi over 4. So you have now found your u and v values. So the sine of pi over 12, we'll rewrite that as pi over 3 minus pi over 4. I guess you could convert this to degrees and figure out what it would be and then convert it back, but I think that you guys are capable of doing it a little bit more efficiently than that. Okay, the formula that we need here is sine of u times cosine of v. There is no sign change. Minus, since this is a minus, cosine of u sine of v. So I need the sine of pi over 3 times the cosine of the v value, pi over 4, minus cosine of, you wouldn't want to do the pi over 4 again, pi over 3 with cosine. And sine went with pi over 3 last time, this time it goes with pi over 4. So there's patterns here. So I need the y value at pi over 3, root 3 over 2, times the cosine value at pi over 4, root 2 over 2, minus the x value at pi over 3, which is 1/2, and the sine value at pi over 4, the y value, root 2 over 2. Order of operations, let's multiply first. Root 3 times root 2 is root 6 over 4. 1 times root 2 is minus root 2 over 4. And funny enough, I think that's the same answer that we had before. You have a common denominator, so you can write it as one fraction. Root 6 minus root 2 cannot be simplified. Last thing for today. This video is much shorter than the last one that we've done. We need to condense, write the expression as a sine, cosine, or tangent of an angle. So one angle, not two. So what you have to do is recognize the pattern. Is this the sum of cosines? Is it the sum of sines? What are we looking at? Is this a tangent problem? So when you look at this, you should look at your identity sheet and recognize that this is a pattern for cosine. Cosine, cosine, sine, sine is when we do the cosine of u and v, two angles, and then you need to remember that cosine is the one that has a sign change. So if you see a negative sign here, you're actually working with a positive. So you have the cosine, your u value is 60, your v value is 10. So you really want to express this as the cosine of 70 degrees. Done. Why don't you try the next one on your own? Hit pause and try the next one on your own. Okay, last problem for today. Looking at this, I'm looking for a pattern. You guys, these patterns have to jump out at you while we're in this chapter. You see a sum. And you see sines and cosines. So I hope you recognize this as the sine of u cosine v plus cosine u sine v. And that would be a sum of sines. Sine, I did not mean to put the parenthesis up front there. The sine of u plus v. So what's your u value? Well, it's this angle right here. Sine of 4 pi over 9. And the v value, the angle that represents v, is pi over 8. So you have to use your Algebra 1 skills that you learned, or maybe it was 5th grade or 4th grade, I don't know. We need to add fractions. We need a common denominator. So 4 pi over 9, I'm going to spread this out just a little bit, plus pi over 8. And I'm going to multiply this by 8 and this by 8. And this gets multiplied by 9 and 9. So the sine of 32 pi divided by 72 plus 9 pi divided by 72 simplifies to one angle, which would be 41 pi over 72. And that's the answer. All right, a joke for all you K-State fans out there. Specifically, I can think of Carter and Kelly and Carolina, and sorry if I've left off a few of you, but I hope you get a kick out of this one. What do you call a K-State grad with a Big 12 championship ring? Ah, you guessed it. You call him a thief. Ha ha ha, but ching. Have a good night.